Okay, so we're going to start this conversation, a conversation about chemistry, with the definition of a couple terms, atoms and molecules, and then we're going to give several examples of atoms and molecules, and then we're going to finish with the definition of chemistry. Okay, so first of all, atoms are defined in TRO, 3rd edition, page 3. That is Principles of Chemistry, a Molecular Approach, 3rd edition, page 3. And atoms are defined as the submicroscopic particles that constitute the fundamental building blocks of ordinary matter. Okay, let me read that again. Atoms are the submicroscopic particles that constitute the fundamental building blocks of ordinary matter. Now, it turns out that most matter does not show up in nature as atoms. It usually shows up as molecules. And so in order to understand chemistry, or the features of chemistry, or how materials act, we're going to need to understand molecules. And let's define molecules here, also on page 3. Molecules are the geometric arrangement that are formed by atoms that are bound together. Let me give that again. They're the geometric arrangement that are formed by atoms that are bound together. That's what molecules are. Okay? So I'm going to show you a couple examples of atoms and molecules before we define chemistry, and then we'll be done with this introduction. So first of all, let's look at a molecule that's in your blood called hemoglobin. Hemoglobin is an oxygen-carrying molecule in your red blood cells. Very important, critically important. It carries oxygen. So breathing would be no good. It would be useless to us if we had no hemoglobin. So in hemoglobin's a really big molecule. This is sort of a cartoon of a hemoglobin molecule here. And inside that molecule, there's a little seat for an oxygen molecule. And that oxygen molecule is that right there. Okay? Now there are 4 seats in this big molecule for oxygen. There's a seat in here, a seat in here, a seat in here, and a seat in here. It's called a binding site. I'm going to call it a seat because we might think of it like a car or a bus or a train. And inside there, the oxygen molecule fits. Now, it turns out carbon monoxide is another molecule which is a lot like molecular oxygen in size. There's 2 atoms in it, a carbon atom and an oxygen atom. And that's the reason why carbon monoxide is so poisonous, because it can get into that seat. And frankly, when it gets in, it doesn't like to get out. That's the real problem. All right, so here's an example. A better picture of a carbon monoxide molecule. The first example of a molecule is carbon monoxide that I'm going to show you, and you can see that it's made up of a carbon atom, which is signified here as a black sphere, and an oxygen atom, which is signified as a red sphere. Okay, the next example of a molecule that I'd like to show you is carbon dioxide. And in carbon dioxide, we have 2 oxygen atoms for every carbon atom. Okay? So again, examples of atoms so far that you've been given are carbon atoms and oxygen atoms. And none of the examples of molecules are hemoglobin, oxygen, carbon. And let me give you another. I'm sorry, oxygen. No, I'm sorry. I misspoke. Hemoglobin, carbon monoxide, carbon dioxide, and oxygen, molecular oxygen, which I haven't shown you. All right, and then 2 more examples of molecules are water and hydrogen peroxide. And look at this. There's an oxygen atom in the center of a water molecule and 2 hydrogen atoms that are coming off of the central atom. And over here, there are 2 oxygen atoms and the hydrogen coming off of each. And notice, by the way, there's a specific angle these come off here, right? It's no longer like carbon dioxide, which is linear, right? It comes off at a particular angle. And that's not a coincidence, by the way. We'll discuss later in the course why that is. But for now, just notice that it's there. And Trost says, by the way, in the definition of molecules, that the arrangements are geometric arrangements. And there's an example of why he might say that. Okay, so let's finally go back and give a definition of chemistry now. Now that we've sort of discussed what atoms and molecules are, chemistry is the science that seeks to understand the behavior of matter by studying the behavior of atoms and molecules. Now that's on page 5 in your textbook. Again, chemistry is the science that seeks to understand the behavior of matter by studying the behavior of atoms and molecules.